Hey, this is Avi Gutman with another Ask Me Anything event brought to you by quantreasoning.com. I invite you to join me live next time. We do this every Saturday at 11 a.m. Eastern, and you can attend for free by starting your free trial at quantreasoning.com. In this word problem, I wouldn't pause. You know, I like to pause a lot while reading a question. In this one, there's not a lot that I can do before I get to the question mark. Once I do get to the question mark, though, and I realize that the question is about the total number of coins, I find it useful to wonder about the extremes. Like, what's the minimum possible number of coins? What's the maximum possible number of coins? Even though that's not exactly what they're asking for, the act of thinking about it helps me. And I'm guessing that it would help others as well. So I get to the question mark, and I think, well, okay, if I wanted to minimize the number of coins, then I would grab 2 of the 50-cent coins. And that would be it. We'd be done. So there's 2 coins. So it is possible in the extreme to have just 2 coins in the jar. In the other extreme, I would only use pennies, and we would have 100 coins. So it's possible to have 2 coins, it's possible to have 100 coins. Then I look at the 3 options in the Roman numerals, and I also glance at the answer choices. And one of the things that occurs to me is that if 1 and 2 are both possible, then I don't need to worry about 3. Because there's only one answer choice that contains 1 and 2. So that's interesting to know. On the other hand, if 1 works and 2 doesn't, then I'm not done. I still have to check 3, because if 1 works and 2 doesn't, it could be either A or D. There'd be 2 available options. So just worth noting that if we get lucky and both 1 and 2 are available to us, then we don't need to look at 3. And that does sometimes happen. With Roman numeral questions, it occasionally happens where once you've evaluated 2 of the options, you don't actually need to evaluate the third one because you've already eliminated 4 answer choices. So these are all the things that I would be considering at that point. Then I could go in one of 2 different ways. So the first option, which I may or may not actually do at the test, but I think it's great to do at home, is to build a quick table with the different coin denominations and think about a few different ways to get to a total of 100. So we already mentioned the extremes. You'd have just 2 of those and nothing else, or you'd have 100 of those and nothing else. But it may be worth taking a little bit of time to look for a pattern. For example, I could remove 5 pennies from the second option where we have 100 pennies, remove 5 and replace them with 1 nickel. And how many coins would we have total then? We'd have 95 of these and 1 of these. And as I'm doing this, I'm realizing that if we're removing pennies, we're going to have to remove them 5 at a time. I can't just remove 1 or 2 or 3 or 4 pennies because there isn't another coin for me to make up for that. So the column all the way on the left would be going down by 5s. And there may be multiple possibilities for the other columns. For example, if you're removing 10 pennies, do you replace them with 2 nickels or 1 dime? There's 2 options there. But that just kind of gives me an idea of the complexity of this question and how many different options we really have to think about. Thankfully, though, there's only 3 numbers that we really need to test: 91, 81, and 76. So now I'm going to pause and let you all have a chance to kind of strategize your way forward from here. Because as Eric and JD realized, JD, your approach wasn't very strategic. And the reason it wasn't strategic, I think, is because you rushed to the Roman numerals maybe sooner than you should have. Maybe it would have been worthwhile to take a little bit more time thinking about the situation. Think about it this way, JD. If you do take 70 pennies, you'd need to somehow get another 11 coins. Because this option is suggesting that we have a total of 81 coins. Mm-hmm. So if 70 coins are pennies, and you still need to use another 11 coins, even if you take the smallest coins available, which would be nickels, you're already way past $1. So it wouldn't be possible to use 81 coins, only 70 of which are pennies, because then you'd be over $1, and we need to get to exactly $1.
Oh, it's using 11 times 5 is 55.
Exactly. Yeah, you'd be $1.25 already. We need to be at $1, so it's not. When we look at the numbers 91, 81, 76, one of the important realizations is that we're going to have to use, for all of those, we're going to have to use at least 75 pennies, with the exception maybe of the third one. In the third one, you could use 70 pennies and then 6 nickels. That would actually work as well. So there's two different options to get the 76. 70 pennies and 6 nickels, or 75 pennies and a quarter. But for 81, 70 pennies doesn't work because 11 nickels would already get you over $1. 75 pennies would leave you with another 6 coins, and that's also more than $1, even in the option where you're using the 6 nickels. So you're going to be over $1 whether you use 70 pennies or 75 pennies. And of course, anything fewer than 70 pennies would get you over $1. So then you'd have to think about 80 pennies, but there isn't a 20-cent coin, so that doesn't work either, so we're done. So we've just proved that you can't get to $1 using 81 coins, because using 75 pennies or fewer would definitely get you above $1, and then using 80 pennies also doesn't get you to exactly $1, because we'd need a 20-cent coin, which doesn't exist. And I think the important takeaway from here has nothing to do with coins. It has to do with being strategic. And the strategy here was to start with thinking about extremes, minimizing and maximizing, and then think about the fact that whatever number of pennies you're using, it has to be a multiple of 5. So we're using a bit of divisibility there. Again, the reason why it has to be a multiple of 5 is because your sum of 100 cents is a multiple of 5, and all the other coins are multiples of 5, 5, 10, 25, and 50. So then the number of pennies you're using has to also be a multiple of 5, otherwise you'd have a remainder. So that's part of the strategy as well, right? So we're using a bit of divisibility, we're using a bit of minimizing and maximizing, and we're going one by one through the options and realizing, hey, for 76 coins, you're going to have to use at least 70 pennies, because anything fewer than that, you'd get to over $1. And for 81, you'd need at least 80 pennies, because anything fewer than that, you'd get to over $1. And for 91, well, let's think about 91. Could you use 80 pennies? No, because then you'd have 11 nickels at least, which is way more than $1. Could you use 85 pennies? No, because then you'd have another 6 coins, which again would minimum be nickels, and that's over $1. So it has to be 90 pennies, and that extra coin would be a dime. So once you look at it that way, you realize there's actually not that many options to consider. So the key there was to start from the direction of the pennies. Like, how many pennies could I have here, and what would that mean for the sum of the money in the jar? The big takeaway is the strategy. Like, don't just jump into action. Take a bit of time in the front end to plan out your approach. Can anyone think of maybe some way to visualize that first sentence? Now we're ready to read the second sentence, which says, the one who takes no salt, Do we know who that is? Who's the one who takes no salt? I don't know who that is. But whoever that person is, the one who takes no salt takes no pepper. So whichever is the minus on the S column will also be a minus in the P column. So the minus minus for S and P will be in the same row. Okay, I'm going to read on. And the one who takes no peppers, so that's the one with a minus in the P column, takes no relish. What does that tell you? Where should we put the minuses? Do you know which row they go? I don't know which row will have the minuses, but I do know that all three minuses will be in the same row. Which row? I don't know. But that's really the big inference for this question. So if we don't care who's A, who's B, and who's C, I mean, I don't know what their names are, I'm just going to put plus, 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 and then give C the minuses. And just keep in mind that all of these are interchangeable. I don't know kind of which one is which, but one of the rows has all the minuses and the other two rows have the pluses. Or in simple English, one person takes all three condiments. Excuse me, two people get all three condiments and one gets none. Now we're ready for the Roman numerals. Is it true? It must be true that the person who takes no salt also takes no relish? Yeah, that would be the person who takes none. It must be true that any of the three persons who takes pepper also takes relish and salt? Yeah, because we know that people either take all or none. Two people take all, one person takes none. So 2 is also must be true. Let's go ahead and eliminate anything that doesn't have both 1 and 2 in them. Okay, we're down to 2 answer choices. It must be true that the person who takes no relish is not one of those who takes salt. The person who takes no relish. So if you took no relish, you're not the one who took salt. Yeah, that's true. If you took no relish, then you're the one who took nothing. You're not the one who took salt. Somebody else took salt. Actually, the 2 other people took salt. So the one who takes no relish is not one of those who take salt. So they're all true, and the answer is E. This is a lot more like an LSAT question than a GMAT question. Nevertheless, it's an official GMAT question, so there you go. When I see a complicated sentence like that, I just try to role play, put myself in the shoes. So now I'm the person who took no relish, right? So I'm imagining that I don't like relish, which is not hard to imagine because I don't like relish. So I'm that guy. And is it true that I, the one who took no relish, well, hang on a second, what do I know about myself? If I took no relish, then I also took no salt and I also took no pepper, because the person who took, either you took everything or you took nothing in this question. So I'm the person who took nothing. Is it true that I'm not one of those who took salt? Yeah, I'm not one of those who took salt. So I feel like it's a lot easier for me to comprehend the double negative sentence when I pretend that I'm the person they're talking about. Hey, I'm just going to interrupt my own video for a moment here. If you're finding value in this video, please let me know in the comments below. And give this video a thumbs up. It really motivates me to keep uploading a new video every day. Alright, back to the video. We are trying to cross 4,000 feet approximately, which is almost a mile, according to this. And we know that we're going at 20 miles per hour. So 20 miles would take an hour. 1 mile would take less than an hour. Everybody agree? But how much less than an hour? If 20 miles take a full hour, 1 mile would take 1/20th of an hour. What's 1 over 20 of an hour?
3 minutes.
3 minutes. So I can do a mile in 3 minutes, but I don't actually want to do a whole mile. I want to do a little bit less than a mile. I want to only do 4,000 feet, not 5,000 feet. So it should be just under 3 minutes. So I don't know, maybe the most important word in this question is the word approximately. We don't actually have to do any math. We just have to say, look, at 20 miles per hour, I would be doing 1 mile in 3 minutes. And the reason I was interested in 1 mile is because the distance that I want to travel is almost a mile. So a mile would take me 3 minutes. I'm doing a bit less than a mile, so that'll be 2 minutes. And what Surajit was saying is that it's clearly more than half a mile. Right? 4,024 compared to 5,280. It's more than half, clearly. So the answer should be more than 1.5 minutes. Should be somewhere between 1.5 minutes and 3 minutes, and there's only one answer choice in that range. What's interesting about this question is it's the kind of question that earlier on in my GMAT career I would have solved algebraically in over 2 minutes, probably. And now I would never dream of approaching a question like this algebraically. It wouldn't even cross my mind. So this is the type of question on which I've shifted as more than any other type of question. How does anyone have an idea on how to approach this without a bunch of algebra? Let me see if I captured what you were suggesting there. It sounds like you were suggesting that we imagine that Francine traveled a total of 100 miles. 40 miles at 40 miles per hour and 60 miles at 60 miles per hour. Is that right? Is that what you're, so she was traveling 1 hour at each speed. And you're saying if she traveled 1 hour at each speed, then her average speed would have been just the average. It would just be a regular average of the two speeds. So it'd be 50 miles per hour. And then you said, okay, so if she traveled an hour at each speed and for a total of 100 miles, then what percent of the distance did she travel at 40 miles per hour? 40%, because the total distance is 100%. So she traveled for 1 hour at each speed, 40% of the distance at the lower speed, and 60% of the distance at the higher speed. And if you're going with all of that, then in that circumstance, your x is 40, as we said, because it's 40% of the distance at the lower speed. And the answer would be 50 miles per hour average speed. It's just a straight up average because she spent the same amount of time at each speed. Did I capture everything you said correctly, Surajit? So let's go one by one with Surajit's suggestion, and then I'll offer another way to solve this. But if we go one by one, 180 minus 40 over 2, is that 50? No, it's 70. 40 plus 60 over 4, is that 50? No, it's 25. 300 minus 40 over 5, is that 50? No, it's 52, right? 600 over, what's 115 minus 40? Isn't that 75? And this would be 8, which is not 50. And the last one, 12, well, we don't even need to try the last one. It has to work, because one of them has to work. But just for fun, 12,000 over 240, yeah, that's 50. So it's E. So that's one way to solve it. Now, some of you may be thinking, it kind of feels a little bit like Surajit got lucky. Right? He chose values that worked out. And what if you had chosen different values, or what if you hadn't thought of that particular example, or what if it was a different question? If you're thinking that, then we should see if we can solve it another way. But Surajit, well done. I think the big insights that Surajit used there are, one, if you spend the same amount of time at each speed, then your average speed will just be a straight up regular average of the two speeds. And two, he used 100. He saw the numbers 40 and 60. I think this was the very first thing you said, Surajit. You're like, hey, 40 and 60, that adds up to 100. Why don't we just imagine that the whole distance is 100 and she spent 1 hour at each speed? So that made the numbers fairly easy to work with. So I think those are the two insights that Surajit used there, and that's great. So I want to share with you where my mind goes when I see a question like this. The first place it goes is, I find it interesting that in some answer choices x is in the numerator, and in some answer choices it's in the denominator. In some of them x is positive, like it's being added to something, and in other cases it's being subtracted from something. And where my mind goes is, I should be able to use logic to eliminate some of these options based on whether the answer should get bigger as x gets bigger, or whether the answer should get smaller as x gets bigger. In other words, are they positively or negatively correlated? So I go back to the question and remind myself, what does x represent? And x represents the percent of the distance covered in the lower speed. And I'm thinking, if I cover more of the distance in the lower speed and less of the distance in the higher speed, like if I'm doing that, what would that do to my average speed overall? Would my average speed be bigger if I covered more of the distance at the lower speed? Or would my average speed be lower if I covered more of the distance in the lower speed? And if that's hard for you to think about, go to the extreme. What if x is 100? What if the entire distance was covered in the lower speed? That would minimize my average speed. So the insight that I have there is that as x is bigger, the answer should be smaller. So A does make sense, but B doesn't, and D doesn't. Because in D, if your x is bigger, but you're subtracting it from the denominator, your denominator would be smaller, which would make the whole answer bigger. And what did we say? If x is bigger, the answer should be smaller, not bigger. So B and D are gone. So that's where my mind goes when I see a variable being in the numerator in some cases and the denominator in the other cases, and being added versus subtracted. I've eliminated two answer choices. The next place I'll go is I'll pick the easiest number I can possibly think of for x, which in this case would probably be 0. If x is 0, that means Francine is traveling the whole distance at the higher speed, and the average speed would just be that higher speed of 60. So if x is 0, answer is 60. So I'm saying if x is 0, the answer should be 60. And that eliminates A, because A would give us 90 if x is 0. Unfortunately, we still have C and E. Both work if x is 0. And if you try x equals 100, which is the other extreme, there the answer would be 40. That also works with C and E. If one of these remaining two answer choices fell off with trying one of the extremes, then you're done. In this case, it didn't, and unfortunately, David, even when I tested the other extreme, it still didn't. Because if you plug in x equals 100 into C, you'll get 40, and into E, you'll also get 40. So C and E still stand even once I've tested both extremes, which is just their way of making the question a little bit harder. They're forcing us to test a number that's not an extreme. So I'm going to use one really important insight for the GMAT to finish this off. And the insight is the following. If the same distance is covered using two different speeds, the average speed will always be closer to the lower speed. And here's why. If you're covering the same distance at two different speeds, you're going to spend more time at the lower speed. Think about that logically. If you're covering the same exact distance at two different speeds, you will take longer at the slower speed. Meaning that when you do the weighted average for the speeds, the weighted average will be a little bit closer to the lower speed because you spent more time at that lower speed. And that's an insight that I've used on many official GMAT questions. So maybe I'll say it just one more time. If you cover the same exact distance in two different speeds, so you're covering a distance at a low speed and you're covering the same distance at a high speed, you must have spent more time covering the distance at the lower speed, because if you're going slower, it takes more time. Which means that the average speed will be closer to the lower speed, since you spent more time at that lower speed. So it's a weighted average, and it will be closer to the lower speed than it is to the higher speed. And using that insight, going back to the question, I would put in x equals 50, so that we're covering the exact same distance at each speed. And I'll say then that the answer must be just under the midpoint, just under 50. Now, if you try answer choice C, C is the trap answer. See, a lot of people make the mistake of thinking, hey, if the distance is the same distance, then the average speed is right down the middle, and they would pick C. But it's not right down the middle, it's a little bit lower than the middle, because it doesn't go based on how much distance I covered at that speed, it goes based on how much time I spent at that speed. So it's a classic error. I actually made that mistake myself a few years ago on a GMAT, actually it might have been a GRE question, and then I kicked myself. I was like, oh, I can't believe I made this mistake. I teach this to people. But it's just very, I think our intuition will often lead us the wrong way when it comes to average speed. Intuitively, people, including myself, tend to feel like the weights of that weighted average should be the distance covered. The more I travel, the farther away, the farther I travel at a certain speed, the heavier weight that speed gets in the average speed. But that's not true. It's not the farther you travel at that speed, it's the longer time you spend at that speed. That's what determines the weights in the weighted average. And so if you know that, then you can use that to finish off this question. And that's, I think, the most important takeaway from this particular problem. Because you're not going to have this exact problem on your test, but you're very likely to have something to do with an average speed. And this insight is very likely to be useful to you. If you found this video useful, go to quantreasoning.com for a lot more where that came from. You should also click that like button and let me know in the comments below what you'd like me to make future videos about. And of course, if you haven't yet subscribed, go ahead and do that and click that bell below so you get notified about future videos. See you next time.